Right, fourth technique will be on sum and difference of cubes. So previously we have in terms of squares, and this one is going to be in terms of cube. The idea is going to be pretty much similar. So previously when you have your function that can be written both of the function, the terms can be written in terms of square. So this, when you have two functions, that can be written in terms of cubes. But for the previous one, for the case of, so let's revisit what we have seen before. For the case of minus, where is it? Number 2. Yeah, for the case of difference in squares. So it is only possible to use this when the operation in between them is in terms of a minus. But for the case of cube, so it doesn't matter. We have two separate formulas. You can use it for either plus and also minus. So if I'm not using x or a, so this will be in a more general form right here. So if you have f cubed plus g cubed is going to equal f plus g multiplied by f squared, and in the middle is going to be a product of both of this function. Okay, at the front is going to be the first function square minus product of both, and at the back is going to be plus. So when you have the second function square. Okay, but you have to memorize this. If I'm not mistaken, like it's not going to, this formula is actually not given, but you have to know this. So I have a way of how do I memorize this. So the first thing that I notice about this is that if you notice, so whether it's got to be a plus or a minus, there is only one minus, okay? And the other two is going to be in terms of a plus. So when this is a plus, so x plus a is going to start with a plus, so you have minus in the middle, and the last one is going to be a plus. And when you have a minus in between them, so the first is going to be minus and it's going to be plus plus. Okay, remember? So the first one is going to follow. If this is plus, this is plus. If this is minus, this is going to be minus. And for the first case, minus is going to be in the middle. Okay, so of course, first thing that you have to do is the first function, you have to make it cube, and the second function is going to be in terms of cube as well. So I have two examples that I'm going to show right here. So the first one is going to be t cubed minus 8 cubed. Sorry, minus 8. Let's start with an easy one first. So what happened for this case is that this is already in terms of cube, so I don't have to worry about this, but I have to worry about the constant. But the thing about 8 is that we know it can be written in the form of 2 to the power of 3. So now, from what we have seen before, this is basically my f, and this is basically g. So when I apply the formula, so remember, when this is minus, this is going to be minus. So I'm going to end up with t minus 2. So the first term is going to be this term square. So I'm going to have t square. So I already have minus. This is going to be a plus. And the middle term is when both of this being multiplied together. So that is going to be 2t. And the last term is going to be this term being square. So which is going to equal 2 square. Okay. And of course, like you can also write that. In order to make it prettier, you can write in the form of t squared plus 2t plus 4. And again, you have to always check. This one is already a linear factor. There's no problem with that. But the second factor is actually t to the power of 2. So let's check if that is reducible or irreducible. So I'm going to need a polynomial. And now it's going to be the case of degree 2. So my a is going to be 1, b is going to equal 2. C is going to equal 4, and what happens is that I get complex root, and this is going to be irreducible, so therefore I'm going to leave it like this. We can no longer further reduce this. Okay, that is going to be first example. Okay, second example. So where is my problem just now? You can just copy it from here. So I'm going to have 125, so plus y minus 1 cube. So again, so do not get intimidated the fact that we have y minus 1 cube. So what happened is that you're going to consider this as one function, and the whole thing over here is going to be considered by another function. And the good news is that 125 is actually 5 to the power of 3. If you're not sure what is it going to be to the power of, you can use your calculator and find what is going to be the cube root of 125, and your calculator is going to give you a value of 5. Okay, so here, and the other term is going to be 1 minus 1 cube. So what I'm going to do is I'm going to apply the plus formula. So according to the plus formula, so the first term is going to be f, which is going to be 5 for this case. So plus g, which for my case is going to be y minus 1. So let me use a square bracket over here so that it doesn't confuse us with the bracket inside. Okay, so that is going to be this one. So I have the first term plus the second term. So this is my first term, this is the second term, so that is how it looks like. And I'm going to proceed underneath over here because this is not going to be enough space for me. And then that is going to be multiplied by the first term square, so which is going to be 5 square over here. Remember, when you have plus in the middle, so in the middle is going to be minus. So here I'm going to have minus. So I have to multiply both of this. So which is going to be 5 multiplied by y minus 1. And at the back is going to be plus again. So the second term square. So which is y minus 1 square. So that is how it's going to look like. Okay, so that is basically going to be my factorization. And do I stop here or would I proceed? So I can tell that I'm going to stop right here just having a look at the factors because these are all linear factors. Don't bother with the 2 outside, just have a look inside. So this is already y to the power of 1, so there's no need to reduce that. So that is going to be the simplest way it can be for this case, right? So that is going to be for technique number 4. So technique number 5 is going to be grouping. Actually, this is, some of it are very common, something that we use commonly in maths, but something like this is not very obvious, but you have to look at it very carefully. Okay, so let's have a look at this together. Let me add a page. I'm going to start with the first one. So the first one, I'll end up with ax squared plus ay plus bx squared plus by. So how do you use grouping technique? So it's more to like observing what's similar. So here I noticed that this is actually similar in terms of this 2 group and this 2 can be together as well. So there are 2 ways. Either I can factorize the a or I can actually factorize the x squared. So let's do try and error here. So if I factorize a, I'll end up with something like this. So x squared plus y plus b by x squared plus y. Okay, so that is actually one way to factorize. Or I can actually factorize the x squared, for which I will get a plus b, and y squared, and y is going to be a plus b. So actually both of them would work. So either way, which one you use is going to give you exactly the same answer. Okay, for example here, let's see if I want to group a with a, b and b. So this 2 together, I'll end up with something like this. I'm going to have x squared plus y, and b is going to be, again, x squared plus y. And I can actually factor out x squared plus y, for which from the first term I will get a, and the second term I will get b. So that will be the outcome. Okay, so that's how it looks like for this case. So number 1. Number 2, so I have x cubed minus x squared plus x minus 1. So this is the not obvious one. So how do I deal with this? I notice a similarity between these 2 though. They have a higher power. So what I can do is, like, there are actually, when we do grouping, there are no wrong answer. There are multiple ways of doing this. Okay, as long as like everything is written in terms of a factor, 1 factor, multiple factor, there's no remaining like plus 3 over here. No, we don't want that. So everything has to be in terms of brackets. We don't want anything outside of the bracket. And what I can do with this is that I can actually factor out x squared, for which I'll end up with x minus 1. And here I'm going to have 1 multiplied by x minus 1. So I put this 2 together as well. Okay, so again, I'm going to use what I did before. I'm going to factor out x minus 1. So the first term is going to be x squared. The second term is going to be 1. So I don't have anything outside the bracket. So that is the correct way to do the grouping. You only can have brackets. You cannot have excess and like x plus 2. No, that is not right then. You have to have products of polynomials. Remember, everything has to be multiplied together. No plus, no minus. And then number 3. So I have x squared minus y squared plus 6x plus 9. Okay, this is not obvious, but I noticed something that we can do right here. So this, and this, if you were to put them together, so they can actually be written as x plus 3 to the power of 2. And then you can have minus y squared. And if you notice, this is something that we have seen before. So it's going to be technique number 2, which is different in square. So this is my f function, and this is going to be my g function. So therefore, I can write it, put a square bracket. So I'm going to have x minus 3 minus 1, and the other one is going to be x minus 3 plus y. So that is going to be the outcome, because remember, the formula is that when you have x squared minus a squared is going to be x plus a x minus a. Okay. Let me write that in terms of f and g. I think that is much better than having x and a. I don't want you to get mixed up with x and a that we have on top. So if I have f squared minus g squared, so that is going to equal f minus g multiplied by f plus g. So this is what I did over here. So this is my f minus g. So this is my f plus g, or the other way around. It doesn't matter. And the last one, so number 4. So I have, so this is like, number 4 is something that we usually ask in tests and exam. It looks easy. It's something that you could have done easily, but the thing is that I have actually asked this in test and exam, and there are still students who are not familiar with this. I don't know. I think probably like the fact that we have fraction as being the power, it kind of intimidate them. So that's what I think. Okay, so there are multiple ways of doing this one. It doesn't matter. So pick either way that suits you best, as long as you have multiple factors and everything is in terms of bracket multiplied together. Okay, the first thing that I noticed about this is that they have the same factor, x minus 3, x minus 3. But how do I decide on the power? So usually, so if I have like x squared plus x cubed plus x, so what we're going to do is we're going to factor out the smallest power, right? So I'm going to do the same for this one as well. I have negative a half and 3 over 2. Of course, the smallest power is going to be negative a half. So when I do the factorization, so this is going to be negative a half. So here I'm going to have x, and inside here I'm going to have like x minus 3. But what is going to be the power of that? So the thing that we know is that when you have, for example, a to the power of x multiplied by a to the power of y, so this is going to be ax plus y. So meaning that when I have these two powers, they are supposed to become 3 over 2 again. So I'm going to have negative 1 over 2, so plus whatever that is, so that is going to equal 3 over 2. So my whatever power is going to be 4 over 2, that is going to equal 2. So therefore here, so actually this is going to be to the power of 2. Right, so that is how it looks like. So I'm going to have x minus 3 to the power of negative half multiplied by x plus x minus 3 square. So the question is that can we further reduce this? The answer is no, because this is already linear to the power of 1, to the power of 1, to the power of 1. So just leave it like this. So this is going to be the final outcome, remember? So there's no special way of doing this. Like when you do the factorization of the power, it's actually up to you. So if you decide that you want to do this way, this would be fine as well. For example, you want to write that as, you want to factorize it to the power of 3 over 2 instead. Instead of using the smaller power, you want to use the highest one. I think that would work as well. So here I'm going to have x minus 3. So I'm going to have x at the front, of course. And I have 3 over 2. Now I have 2 to the power. It has to make negative a half. So, but I want 3 over 2 plus whatever power that is going to equal negative 1 over 2. So my whatever power is going to equal negative 4 over 2. and that is going to equal negative of 2. So it's going to be negative of 2 right here. And of course, this is going to be plus 1. So that is how it looks like. So that should be fine as well, as long as when you multiply both of this, so it's going to be the original function. Okay, so sometimes do not like limit yourself to only one way. So there could be multiple ways of actually we're not solving anything over here, of manipulating your function. Okay, so we're done with the topic 1.1, so which is